Welcome everyone, my name is Tatiana and this is my video series on OTF Studio thin film software. OTF Studio is a very powerful, smart and extremely fast tool for multi-layer design, thin film characterization, reverse engineering and monitoring of optical coatings. Optical coatings with specified color properties are used in virtual reality, in architectural glass, automotive glazing lenses, cameras, displays, and many other applications. OTF Studio provides a wide range of features: color designing, color evaluation of designs, color evaluation of produced coatings based on measurement data, color comparison, color difference calculation, and calculation of color-related parameters. In this video, I focus on color evaluation features of OTF Studio. I open my Illustrating OTF Studio project, an example. I will use three materials: aluminum, gold, and zinc oxide, and an absorber design with very interesting color properties. The reference is in the video description. If I open its profile, there are three layers. Two of them are metal layers, and we can switch to a refractive index bar diagram. It's clear that transmittance is 0, but if I open reflectance plot, we can see pronounced feature in reflectance and expect interesting color properties. Open color diagram, and by default, chromaticity's color diagram is opened. And this diagram by default shows only one point. This is color coordinates of reflectance. Reflectance is shown on the left panel, and here we can see chromaticities of this reflectance curve. Here I can configure, using sliding panel, I can configure the diagram, can display multiple characteristics instead of reflectance S polarization, reflectance average. I can increase the number of angular points and increase the angular range, extend the angular range, and change the number of points. And we can see that these points appear dynamically on the color diagram. Instead of reflectance average, I can take reflectance for S&P polarization. It's also interesting behavior, color behavior of this design. On the sliding panel, you can configure the color diagram. You can add, for example, a reference white. You can zoom in and zoom out the diagram, the parts of the diagram. You can add Planckian locus and RGB triangle. If you switch to the table view, you can see the numerical values of the color coordinates calculated with specified parameters. Here you can specify observer, reference white, and two color spaces. If you don't need the second color space, you simply can remove it. So the numerical values correspond to the color points on the diagram. On the top of the color evaluation panel, you can switch between different types of color diagrams corresponding to different color spaces. And on the table view, you can see the numerical values of all color coordinates on the diagram. In many cases, it's convenient to open the second color panel. I place it on the left, side by side. This is a new panel, and it can be configured separately and independently from the first panel. In the first panel, I have reflectance S&P, and here I will have reflectance average, and only one angle 0 degrees, so normal incidence. In the table view, I will have two coordinates in two spaces, chromaticities and LAB. Let's open one more color panel, color evaluation panel. I place it on the top, and I will open it in color page. The color page provides a visual representation of the perceived color computed from the spectral characteristics of the loaded design. Using the color page, you can immediately see how the multi-layer is expected to appear to the human eye. In OTF Studio, you can open multiple color evaluation panels simultaneously and configure these panels independently. One panel can display color diagrams in desired color space. Another panel can display numerical data of color coordinates or color differences. One more panel can show color page or one more color diagram, what you want. It's very convenient. Now I would like to demonstrate interactive color analysis using Variator tool. I restore to my previous settings reflectance average, add some angular points, and extend the angular spectral range up to 75 degrees. Now I switch to Design Builder, Variator view. Variator is the interactive analysis tool of OTF Studio. And here I would like to change thicknesses of these design layers and see what effect they have on color coordinates. When I change the thickness, for example, the last layer, gold, I see how color coordinates are moving on the color diagram, how numerical values are changing in the table, and simultaneously color page and, of course, refractive index profile. The second layer is very sensitive, zinc oxide. So we can see how sensitive and how interesting the curves on the color diagram with changing the thickness of this layer. The first layer is not sensitive, so I can change it, aluminium, but there is no effect on the color properties. So we can see that all panels are updated simultaneously, dynamically, and very fast. I rearrange my layout a little bit, and now I would like to open two diagrams simultaneously. One is chromaticities diagram, another one, it can be LAB, and if the variator is active, the calculations are performed for all color evaluation panels. I can switch to hue, lightness, chroma diagram, and you can see how fast, extremely fast, the computations are performed and the diagrams are updated. On the hue, lightness, chroma diagram, we can see additional settings according to this color space. This is lightness and chroma maximum. And also we can change these values and have different views of the color diagrams. I hope you find this video useful. Many thanks for watching. If you have questions, you are welcome to contact me, and see you in the next video. Bye!